Good morning. First of all, I would like to thank you for the opportunity to present at a very important congress like LGLC. My name is Felipe Santos and today I'm going to talk about impact on the productive stability caused by the variations of Prestressed precast elements. So, why I choose to study precast production? Firstly, due to the great importance of civil construction in the Brazilian PIB. Secondly, due to the need for a better productive performance of this industry. One of the difference between conventional construction and the production of precast elements is the workplace. Production within an industry has great technological control, which results in greater dimensional accuracy, structural performance, reduced waste, and less construction time. Many precast companies have attempted a migration to the lean production, but have not achieved a substantial transition. The stabilization process is difficult in civil construction, as this sector presents several peculiarities, such as unbalanced workloads, different setups configurations, shape changes and reducing of unique and special projects, and a high rate of absenteeism in the workforce. This research carried out in a case study an industry of precast elements, Factor A, located in the state of São Paulo, Brazil, and which has an installed capacity of 5,300 cubic meters. At the time of the research, this factory is producing 4,000 cubic meters distributed in pillars, beams, and strutting beams as structural elements, solid closing panel, and custom parts. This company is characterized by the high adaptation of the types to meet any need for projects. Thus, an interpretation was carried out through a master research with an action research methodology, allowing the researchers and also the factory production coordinator to try to improve the process. Initially, it was proposed to study the production of prestressed beams. This production is carried out with a protection track. This track is a region between two protection hand lengths. As you can see, one hand length in this picture, each line of this production track, and these are the active hand lengths. While the passive hand lengths are at the bottom. Between these hand boards are the metal molds that serve to shape the beams, as being triple I or as being triple vase. When carried out production, it is necessary to passage to string prestressed steel along the out track. Therefore, with the intention of making the best use of available resources, as string prestressed steel in the only metallic molds, usually several beams are combined in the same track. How the factory builds works of the warehouses, hospitals, shopping centers, hotels, and supermarkets use precast elements. The production of a beam in a shopping mall has a totally different complexity than a beam in a warehouse. The several works, it is necessary to produce according to the available mix. This mix varies with sales and generally interferes with workloads. One stage of the research was to develop a value flow map. On this slide, a simplification of the current VSM is known. Production can be divided into three basic stages: reinforced steel, production, and finishing. A traditional production is commercially perceived with production plan and control, have a program and reprogram as production, with communication between processed activities, with large stocks between processes. After analysis to make the process learner, a factor VSM was proposed. On this slide, there is a simplified representation. First, there is a change in the communication between the processes. Initially, the communication between the reinforced steel and the production can be carried out through a supermaxion flowing. No longer a P.S.P schedule, but a production sequence. As production realizes the molds, it can remove the reinforced steel from the supermarket according to the mold, shape, and the sequence proposed by the PPC. As the production stage ends with calcant, the finished team needs to wait for the part to cure, so that communication occurs in a FIFO flow. Looking at the VSM, identify that it is necessary that the production process is stable. Firstly, consider the currency of the concrete. If the trick is not carried out by the ends of the day, the metal mold becomes unavailable for the no later day, interfering in the production on the reinforced steel and the finishing. This article proposed the impact on product stability caused by variations in typology. Stability is the reliability of the process in carry out an activity with the same quality, duration, and methodology. The stability can be represented directly by the 4 M's. The material stability is found in its available as needed. The lack of material, difficult to remove it, and or low quality can cause interruptions in the development of an activity. In the work labor, to perform an activity, labor is required that does not vary in quantity and capacity, allowing for constant quality and duration. The stable process needs your workforce to show consistency in the execution of the methods and in the required quantity. This requires training and a low rate of absenteeism. If the method must present a sequence of steps that can be replicated in such a way as to guarantee a standard duration and quality, a method must present production standards which serve as comparative parameters and as a basis for the possible improvements. So the machine must, at a minimum, be available as required by the method. This machinery does not need to have perfect uptime, but it does need to meet customer demands, process capacity, and the actual average uptime in the order to guarantee cycle time reliability. Define the basic stability. We have now to check if the production stage is stable. First, it was necessary to divide a station in substations. Preparation, a stage that consists of cleaning the shape, preparing the accessories, and position the reinforced steel in the molds. Passage to string Prestressed steel through the reinforcing steel, and your specific protection. The fourth step is the assembly of the accessories, thus allowing the closing and looking of models. After checking the piece, it is possible to carry out concrete and the curing. Product finish with the opening of the form and the unmodel of the piece. As these preparations, assembly and close stages, they are in bold, have great variation, and has been studied more deeply. These 3 substages were studied along the elaboration of the standards works adapted were proposed. The stages were divided into small activities to be timed and evaluated. The step was be recorded photographically and make a methodology was developed to be followed. Before the standardized works were elaborated, it was possible to verify that each collaborator carries out the activities according to the hour method, interfering in the quality of service duration. In this way, the best feasible method to be followed was studied and determined. After the elaboration, the production team was trained. With the division of activities, it was possible to calculate the estimated time for each of the preparation, assembly, and close activities. For it, I serve 10 stroke average of carry out an activity, number of employees that realize the activity, initial displacement, interference factor, and modulo of interference characteristic. What would this modulo be? When the server was carried out to close a metal mold, the server is actually carried out to close 6 meters of track. As the track characteristic is provided in meter, it is necessary to divide the time by 6. If I research 1 minute to close a side, in fact we have spent 10 seconds per meter. Trained. To better explain the times, this table with the estimated and calculated the time for the assembly activity. As activities are on the left, when analyze a third activity that is performance in the checking square. 10 minutes were collected. These two numbers of table is practically the employees' times closing the entry late of the track and talking the ferraments. In tech stroke of carry out, he spent an average of 43 seconds. So we have that the necessary times is equal to 1 number of employees times or the average time divided by the modulo and was plus to the initial displacement. Therefore, this formula on the right is just the time spent on one activity is the activity of checking squares of the bins. A final formula or estimated the time for the assembly steps is the sum of all formulas on the right. In this way, it is possible to estimate production and improve scheduling. Therefore, the time result is directly proportional to a characteristic which can be number of sets, number of accessories for various connections between precast parts or the other production system, such as metal roofs, clothes, or wood, number of beams, number of string prestressed steel, number of track with table. What is this table? Is a specific assembly step that requires a long duration. In the wood step for connecting a caping piece, the tape serves as a frame for the whole core slab in precast. Volume of concrete and weight of reinforced steel. To allow to verify or impact the variation and to better understand the production families of Factor A, it was collected as characteristics of 14 production tracks. These characteristics are listed in the table below. As you can see, no similarity was found between these clues, which generates the following question: what is the likely impact of these changes of the typology? Then was compared the characteristics with estimated time development formulas with the following dates. Each clue raised occurrence on a certain date, which is to the left of the table. These 3 columns is the estimated time for the 3 stages according to the checklist considered. It is noticed that a track in December, day 40, table was a match right compactly in the assembly stage, with surge a right level of 241% when compared to estimated duration in 12 February. The close and preparation steps research 44 and 24 variations portion respectively. As there is a great difference in complexity between the tracks, it is possible to verify the great difference in the duration of activities on each day. The last activity of the day is the concrete, thus allowing healing to take place on the against shift. If you do not finish the track, force the concrete to take place only the next day, it interferes with the twins' routine. First, and the main problem, the cure will occur through the day preventing the use of the form. Second, as each day starts activities differently, there is no standard routine. This lack of routine directly interferes with product stability. Activities should always take place in the same way and time. Third, as the complexity varies from the track to track, it causes many programming failures. Fourth, when we analyze the future value flow map, we need for this process to be stable was identified. As this is not found, it makes it difficult to change the follow since these oscillations interfere in the predecessor and later activities, reinforces 2 and finish respectively. This moment in the process is essential, as the stage is the main gear. This lack of timing interferes with the interval chain. Finally, when you are at the end of the day and realize that the possibility of finish the track, it is notorious that you run and don't make some producers, thus ensuring that the activities end at the end of the shift. However, a considerable increase in errors, mistakes, is identified when the tracks are finished in this situation. The literature indicates a maximum variation of 30%, a fact that is not found in this production. Thus, a reduction in the size of the runway is proposed. As there is a great difference between the complexity of the piece, it was suggested to divide them into 2 families. As the track has 100 meters, you can divide in 2 tracks of 15 meters and better distribute the mix of typologies. It is also suggested you can specify activities as identified that there is larger variation in complexity. You can invest in a specific automation. In the conclusion, there is a great variation in the typology, and it interferes directly in the production stability. Therefore, management finds difficulties in stabilizing production and manpower leveling the production, make the routine difficult. With this wide variation, every day there is a flow and distribution of the ideal workforce. The management is difficult to determine the best workflow and the actual situable production capacity, the current mix of parts. Doubts? Follow me email below for any future question. I appreciate the opportunity and attention. Here is my email, and best wishes, and take care.